Chapter 3 is quadratic functions, and for a quadratic function, there's something called vertex form. That's when you go a times x minus p squared plus q, and a is not equal 0. The graph looks like this, and my very favorite place to graph is this place called Desmos.com Calculator. And so I entered in f of x or y. I could have put either. Let's even just put f of x. Okay. And I put that general form. And what I've done is it allows me to have sliders. So it allows me to say, okay, what happens when I increase the value of A? What happens when I decrease the value of A? You see something special that happens there. Okay, what about this P value? If I make it x minus 3 or 4 squared, what happens when I adjust my P? What happens? And then finally Q. What happens with Q? Okay. Okay, there's a couple of points of interest, and the first is my vertex. You'll notice my vertex is at 3 and 2.21. Now look what happens when I change my value. As this gets bigger, as I put 5 here, look what happens to the vertex here. Similarly, if I change the value here, if I change the value to 5 or 6, notice what happens to my vertex. So it looks like the values P and Q are really important to the vertex. It has its vertex at P and Q. It has an axis of symmetry at x equals P. So there is like a line that comes down. That axis of symmetry means it divides it in half. It's equal on both sides. So you can see quite clearly that it's going to divide itself when x equals, when we have a vertical line, x equals. That's going to be our, we can actually write that, x equals, actually I can't type all of them. Anyways, that is our axis of symmetry, where it slices it in half and there's 2 equal pieces. It's congruent to a equals x squared. So if we just did the graph a equals x squared, but it's translated horizontally by p units and vertically by Q units. So what we do is we take our graph and we move horizontally P units. So whenever we move our graph, whenever we change P, we are moving horizontal, and whenever we change Q, we are changing vertical. That's all that means. Okay? You can sketch a graph by transforming the graph. Couple parameters. If A is greater than 0, it opens upwards. If A is less than 0, it opens downwards. So here we have a positive A. As soon as we get to a negative A, you can see that that parabola opens downwards. Ooh, something interesting is happening here. We have a couple of points of interest. These are called the x-intercepts, and this is the y-intercept. So that's kind of interesting. We can adjust those as well. Oops. Different values there. We could change our vertex. We could put our vertex over and down. Lots of neat things we can do there. Okay. If A is between -1 and 1, it's compressed. If A is greater than 1, it is stretched. So Q is greater than 0, then we translate up, because remember Q is vertical, and if it's negative, we translate down. P units to the right and P units to the left. Let's try a couple questions. Okay, working example number 1. State the vertex, the direction of opening, and the equation of the axis of symmetry, domain and range, and the maximum or minimum values. Then sketch it. Using the values of A, P, and Q, determine some characteristics of the function and sketch it. So first of all, we have our function. We're going to quickly write in that this is A, this is P, and this is Q. So the vertex is always PQ. Okay, that's what the vertex is, PQ. But notice it's X minus P. Here we have x plus 4, so it's actually minus -4. So P is actually -4. So my vertex is at -4 and 1. We're going to keep that positive 1 because remember our form is x minus P plus Q. So that's the number one mistake people are going to make, okay? They're going to say, oh, it's 4, 1. No, it's -4, 1 because it's always x minus P. Whenever you get a positive, basically you switch the sign of what you see. Okay, since A is less than 0, the graph opens downwards. You didn't remember that, that's on the first page. The equation of the axis of axis of symmetry is always x equals p. P in this case was -4. The domain. So what this is talking about is, I'll go back to a graph here. Domain is all the values of x. So that what that means is this graph, what are all the values of, and it's a downwards, so maybe I should do it downwards. I'm going to do a bigger looking graph. So what values of x could this take? This graph could take every x value. If you kept on going, if you kept zooming out and zooming out, eventually, if you went far enough, this is going to spread out and it's going to hit every single value of x, especially if we made this quite a bit wider. You could see that it would eventually get every value of x. It's going to take a while, but it would. So x is any real number. That's what it says here. X is any real number. The range. Well, since it's downwards, it's as if you have your parabola here. Oh, I hate when this does that. It's as if you have your parabola here, and it's going to be all the y's less than your vertex. So your vertex y value was 1. So all y that are less than or equal to 1. So is there a maximum or a minimum? It looks like there's a maximum value. So there's a maximum value of 1. Y is equal to 1. So this is another thing that's difficult. Determine the coordinates of a point other than the vertex on the graph. Choose an x coordinate and determine the corresponding y. So here they said, well, what happens when x equals 3? What they did is they took the formula given to us, and whenever they saw x, they put in a number, and they chose -3, and then it spit out a y. So it spit out a point. Okay, so they sub this in, and they got, so they got -2. So there's a point at -3 and 2. And we're going to graph that point. So when x equals -3 and 2. There's one point. Since every parabola is symmetric about its axis of symmetry, so what was its axis of symmetry? Was x equals -4. So here's our axis of symmetry. X equals -4. What that means is whatever is on this side is going to be mirrored on the other side. So since it's 1 unit away, I'm going to do 1 unit away there. Its vertex, we can remember, was -4 and 1. So -4 and 1 was its vertex. So we can see that this is going to be a parabola. It looks like this. Wait a second. Didn't we say it was downwards? We did say it was downwards. So it was at -4, x is equal to -4 and 1. We have, oh, because it was 3 and -2. So I put these points in the wrong spot. Sorry guys, so I didn't put -3, -2. I forgot that we subbed in -3 there. So when I move this around, I hate how it does that. So now I actually graph the point -3 and -2. So that is my point. And I'm going to have a parabola, a beautiful parabola drawn on a computer screen, which Ms. Canton is not so good at. That is what the parabola looks like. The good thing is that we always have the internet to help us out. So if we ever wanted to check, I could come here and I could actually type in my equation. Okay, so my graph was f of x equals, we had -3 x plus 4 squared, and then we had +1. Okay, so I want to get rid of these points of interest so I can see. I want to zoom in because it zoomed out quite a bit. And that is what this looks like. Okay, I still want to zoom in. So you just zoom in by scrolling on your mouse key. That's the easiest way to zoom in. So we had -4 and -1. We had -3 and -2. Yep, that looks really good. Those are all points on the graph. So we can always check our work in that way. Okay. So just getting used to how we take something that is in vertex form and how the values of P and Q and A, how they affect it, okay? So this page is really important. It has a lot of information. The other thing you're going to use quite often to check your work is this Desmos Calculator. So I always just Google Desmos, and then it comes up and it says there's beautiful free math, and I always look for the graphing calculator. Okay?